This is the 11th video in my series on alternating current. In this video, we're going to take a closer look at examples of how to add and subtract phasors, as well as multiplying and dividing them. You'll find this topic along with others in my course entitled Basic Fundamentals of AC Circuit Analysis. You can access this and my other courses on my Stan Store at this web address. So when dealing with addition and subtraction of phasors or complex numbers, which phasors are, you simply add the real components of the complex number to determine the real component sum, and you add the imaginary component to determine the imaginary sum of the phasors. So in our example, we have 3 here. We have in the first example on the left, you have a phasor 2 plus J5 added to 4 minus J3, which would give you the resultant phasor of 6 plus J2. The middle one is 175 minus J34. When added to phasor 80 minus J15, you'd end up with 255 minus J49. And the last one, minus 36 plus J10 added to a phasor of 20 plus J82 gives us a phasor that would be minus 16 plus J92. So when subtracting complex numbers, it's almost as simple as adding them together. You either subtract the real components and the imaginary components to come up with the real and the imaginary component of the resultant. Or another way you can say it is you can change the sign of the phasor that you want to subtract. As we're doing here, we're putting a minus sign in front of the brackets, which essentially changes the sign of the terms inside the bracket, then just add them together. Either way, you will come up with the same answer. So in the first example, you got a phasor 2 plus J5, and you're going to subtract the phasor 4 minus J3. So you could change the sign of those components. Minus 4 would be minus 4 plus J3. Then you would take 2 minus 4 is minus 2. Then you'd take plus J5 plus J3 would be J8. In the middle one, you got 175 minus J34, and you're going to subtract 80 minus J15. So you could change the sign of that phasor. So now you would have minus 80 plus J15. So 175 minus 80 would be 95, and minus J34 plus J15 would give you minus J19. And finally, in our last subtraction, you would have a phasor minus 36 plus J10, and you're going to subtract 20 plus J82. So you change the signs of those two components of that phasor, so you'd end up with minus 20 minus J82. So you'd have 36 minus 20 would give you 56 for the real component, and plus J10 minus J82 would give you minus J72 for the resultant. For multiplication and division of phasors, polar notation is favored over rectangular notation because it's much easier to deal with. When multiplying complex numbers in polar form, we simply multiply the polar magnitudes of the two complex numbers to determine the polar magnitude of the product, and we add the angles of the complex number to determine the angle of the product. So let's look at a couple of examples. If we had 35 at 65 degrees multiplied by 10 at minus 12 degrees, you'd multiply the two magnitudes to end up with 350, and you would add the two angles together. So 65 minus 12 would give you 53 degrees. So the resultant would be pretty easily calculated, is 350 at 53 degrees. Another example would be 124 at 250 degrees times 11 at 100 degrees. So you multiply the two magnitudes, ending up with 1,364, and you would add the two angles together, so you'd end up with 350 degrees. Or you could describe it as minus 10 degrees as well. So you would add the angles together to get the resultant angle, which is 350 degrees. So your resultant would be 1,364 at 350 degrees, or 1,364 at minus 10 degrees. And our final example is a simple 3 at 30 degrees times 5 at minus 30 degrees. You'd end up with multiplying the magnitudes together, you get 15, and you would add the two angles. 30 minus 30 gives you 0. And as you might have guessed, division of polar form complex numbers is the easiest path to take. You simply divide the polar magnitudes of the first complex number by the polar magnitude of the second complex number to arrive at the polar magnitude of the quotient, and subtract the angle of the second complex number from the angle of the first complex number to arrive at the angle of the quotient. So a few examples just to cement the idea. Here we have a phasor 35 at 65 degrees being divided by a phasor of 10 at minus 12 degrees. You would divide 35 by 10, which would give you 3.5, and you'd subtract 12 from 65, which is same as adding 12 to 65, which would give you 77 degrees. In this example, we have a phasor at 124 magnitude at 250 degrees being divided by a phasor of magnitude 11 at 100 degrees. So you would divide 124 by 11, which would give you 11.273, and you would subtract 100 from 250 to arrive at 150 degrees. And a final example would be phasor 3 at 30 degrees divided by 5 at minus 30 degrees. You would have 3 divided by 5, which is 0.6, and then you would subtract 30 degrees from minus 30 degrees from 30 degrees is the same as adding 30 degrees to 30 degrees, which would result in an angle of 60 degrees. So the resultant quotient would be 0.6 at 60 degrees. This video is part of my Electrical Technical Information series. In this series, I'll be covering essential topics to help you understand electrical systems. Be sure and stay tuned, as I will also, from time to time, be reviewing electrical products that, in my opinion, are worthy of paying attention to. This address will give you access to the supplier of the aforementioned type products. It is also a connection to obtain a free copy of my 24-page 3-phase transformer workbook, which will serve as a quick reference and reminder of technical calculations that you may need. This address, of course, is case sensitive. I'll spell it out and make sure that you have it right. Everything up to the first number is lowercase. That is lowercase https://bit.ly/3, then uppercase U, uppercase G, a lowercase j, uppercase B, uppercase I, and lowercase g. One of those amazing and versatile products is the 𝐃𝐈𝐒𝐂𝐋𝐀 Delta Pro Ultra, which can be modified to suit any homeowner's needs, operating virtually silent, and when paired with the 𝐃𝐈𝐒𝐂𝐋𝐀 Smart Home Panel 2 is extremely versatile. The 𝐃𝐈𝐒𝐂𝐋𝐀 Home Panel 2 ties any and all of your standby power equipment together and will control them efficiently. It will even control your connection to the utility grid to make sure you're only using the least expensive power, switching to your standby power during those expensive time of use rates. In order to view the full range of 𝐃𝐈𝐒𝐂�'s products and obtain a free copy of my 3-phase transformer workbook, check into this web address and simply provide your email address, which will guide you to browse the full extent of their products. There is no cost or commitment for viewing, and by providing your email address, it will allow me to keep you posted on future videos, courses, and 𝐃𝐈𝐒𝐂 products.